Hello everyone, my name is Omar Bayhum and I'm a master's student at University College London. Today I'll be talking about the Azure Sphere hardware definition tools, which are a set of IDE extensions designed to help developers be more productive when building apps on the Azure Sphere platform. This is a project that's being worked on by my team members listed here as part of an industrial exchange program between Microsoft and UCL. So the Azure Sphere hardware definition tools are basically extensions for Visual Studio and VS Code, which use static analysis to help developers write and fix their hardware definitions. As of today, the Azure Sphere SDK has this great concept of hardware definition files, which let you abstract the low-level pins of an IoT device's microcontroller and map them to more meaningful names. But since these hardware definitions are just JSON files, if you ever make a mistake, you only find out at compile time or at runtime after deploying your code to your Azure Sphere board, at which point you'd sift through log messages to try and figure out what exactly went wrong. The extensions make this whole process easier and less error-prone by notifying developers about potential mapping conflicts in real time and suggesting alternative pins that would be valid. We managed to do this by emulating the pin allocation process based on the Azure Sphere microcontroller's hardware specifications, so that users can get quick feedback as they modify their definitions. Now, what does this look like in practice? Well, let's say I have a simple IoT application which consists of blinking LEDs of different colors. Here I have a project for that application and I'm going to check out its hardware definition file so that I can add some more colors to my LEDs. And once I open the file, the extension automatically detects it as a hardware definition and asks me if I want to add the JSON schema to support type hints. Right now I only have one pin mapping, which consists of a GPIO pin for the green LED. And let's say I want to add a PWM so that I can have a slowly fading blue light. So you'll notice I'll automatically get type hints and I'm going to add a fading LED blue pin of type PWM. And then when it comes to the mappings, I'm probably going to have some trouble remembering what's the name of all the PWMs within the MT3620 RDB board in here. Thankfully, the extension will actually suggest all of the available pins that correspond to the type that I want to add. In this case, I'm going to add the PWM controller 2, which controls one of the LEDs on my board. But I'm not done yet. I'd like to add one more LED, this time another one that blinks on and off using a GPIO, and let's say I want a red one, so I'll add a blinking LED red of type GPIO. And then for the mapping, I'm going to base it off of this one. If I've got a duplicate mapping, I get notified, so I'm just going to change this to something else like red 1 LED 1 red. But it turns out that this is going to cause a problem, and the extension tells me that the pin that I tried to map to, so the LED 1 red, is actually configured as a PWM by the fading LED blue pin that I just mentioned earlier. And this is because on this board, the LED1 red pin is actually shared with the PWM controller 2 pin. So that means that I can't have both active at the same time on my application. And normally I would found that out after deploying my app at the last minute, which would have cost me quite a bit of time. And thanks to the extension, I can just make these modifications on the get-go, and it'll suggest to me the pins that it knows won't cause a conflict once I deploy my application. So in this case, I want another LED, and let's say I'll just go for an LED for red. All of the features that we just saw are also available on the Visual Studio extension, which offers us warnings and auto-completions similar to the VS Code extension. And the great thing about this project is the fact that it uses the language server protocol, which lets us reuse the same code base for the main parts of the application, specifically the pin validation and emulation, and then interface appropriately with the different IDEs. The extensions are in active development, and we're working on a couple of features that are coming out soon. Specifically, we're giving developers the ability to port their hardware definitions to different underlying Azure Sphere boards, which means they'd only have to write one hardware definition for a given board and could support different hardware if they'd be interested without having to manually rewrite their definitions. Then we're working on detecting peripheral conflicts between partner applications without having to deploy them to find out about any potential errors. And finally, we're giving developers the ability to automatically generate pin mappings based on the kind of peripherals that they wish to add without them even having to edit the hardware definitions manually. Everything that we've just shown is actually fully open source and available on GitHub at the link above. You can either build the project from source or download the installers for the extensions and try them out yourself. Feedback or any kind of suggestions are more than welcome, and we're actually really looking forward to hearing what your thoughts are.